Geometry, Unit 7, Section 3. There is no video for Unit 7, Section 2. So the previous video here was video Section 1, where you described the sequence of similar transformations. And it was basically taking the rigid motions that we've discussed in prior chapters and adding dilations to it. And the dilation motion you always want to do is the last motion. And for a dilation, you have to say what point you're dilating about and by what ratio. And remember, we could do new over old corresponding segment lengths for that ratio. So this is called the angle-angle criteria, but let's take a look at this example here. Triangle LMN is similar to triangle MPL. Remember, the similar symbol is like the congruent symbol without the equal sign. And it's not the double wave, that would be approximately, that's different. So a single wave means similar. And what this really means is that their corresponding angles are congruent. Corresponding angles are congruent, and corresponding sides are proportionate. But we're not going to be talking about that in this video. We'll probably talk about that in the next video. This one, we really want to focus on this corresponding angles are congruent and how we could use that to show that two triangles are similar. Here we're told they're similar, and so that means corresponding angles are congruent. Now, first of all, there's three triangles in this picture, so let's highlight the ones that we're really working with. Triangle LMN is this small triangle on the right side over here. That's LMN. And at a quick glance, you might assume that it's the left triangle that we're working with, but it's not. MPL goes from M to P to L. And so we're talking about these two triangles are similar. So whenever you have an option that has multiple triangles or together they form a triangle, it's really important to figure out which ones you're working with, because if you thought it was these two, that would be a major problem. In fact, these two triangles do not look similar to each other, and so that would be an issue if you thought that they were. Now, they tell you that angle P is 20 degrees, so let's fill that in. And then what we want to realize is that, remember, when they list the triangles, they list them in corresponding order. So that means that angle L corresponds to angle M. So angle L of this is the small triangle, this is the large triangle. So angle L of the small triangle corresponds to angle M of the large triangle. And angle M actually is also an angle of both triangles here. So we see those angles are going to correspond, and angle P of the small triangle, angle M of the small triangle corresponds to angle P of the large triangle, and that's this 20. So that's important because that means that these angles are congruent, and therefore this has to also be 20 degrees, because P from the large triangle is congruent to M from the small triangle. And that's really important because that means that this triangle, this big yellow triangle, is isosceles. That this side is congruent to this side because the angles opposite those are congruent. And so that means this green triangle, which is similar to it, must also be isosceles. And that's going to have to be these two sides are congruent to each other. And so just as in the big triangle, the angles opposite are congruent, both 20. In the small triangle, angles opposite are congruent. They must both be 20. And that was really the key to solving this question then, because, you know, in the green triangle, we got 20, 20. This would have to be 140 because they all add to 180. This is supplementary with 140, so it's 40 together. That's 60, so this is 120 up here, and that's all of our angles, and that's the end of the problem. But corresponding angles congruent, and when they list them, pay close attention to that. So that was a difficult question, I believe. Are the two given triangles similar? If yes, find the missing side and angle measurements. Okay, well first, it's always easiest to find the angle. Whenever I'm given two angles, automatically find the third. So I got 60 and 100, that's 160. That means this has to be 20. These are 60 and 20, a total of 80. This has to be 100. So are these two triangles similar? Yes, they are, because they have the same angle measurements. They each have an angle 20, an angle 60, an angle 100. Angles are congruent. Corresponding angles are congruent. So now that we know that they are similar, we can find the missing sides, call this x, this y, by doing the fact that the sides are proportionate. I see that 2.5 is between 60 and 100, so is 3.75. So that means 2.5 corresponds to 3.75, and that ratio will be equivalent to these other sides here too. So 8 in the small triangle between 20 and 60, that's unknown side y in the large triangle, and x in the small triangle between 20 and 100 corresponds to 12 in the large triangle. And so we could do a little cross multiplying here. 8 times 3.75 and divided by 2.5 will get me y, which is 12. And so this is 12, and again we could cross multiply here to get the other piece. So let's do 8 times 12 divided by 12. Well, I can just tell that's going to work out to be 8. 8 over 12 equals 8 over 12, right? So this equals 8 and this equals 12. So, but we determined that they were similar by the fact that all the angles were congruent. All right, one more question I want to do with you today, and it is a proof. Yes, we are going to do some short proofs in this chapter, but not a lot. And what we're going to look for here is the angle-angle criterion. Now notice that it's not angle, angle, angle. Why is it not angle, angle, angle? You know, for congruency, it was always 3 things: side, 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 angle, side, angle, side, angle. So why just 2 A's? Well, because if you have 2 angles, there's only one option for the third. You know, like for this, if I knew I had 60 and 100, well, then this had to be 20. And if I knew this was 60 and 100, then this had to be 20. So you can get away with just proving 2 angles congruent, then automatically the third one has to be congruent, and that's enough to prove the triangles are not congruent, but similar. Remember, we never did angle, 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 or angle, angle for triangle congruence. We do that just for similarity. So let's create a little statement reason table. Statement and reason table. And so we're trying to get a couple of angles congruent here. Congruent to prove the triangles are similar. Now, where are these triangles? Let's see. Triangle ABE is here. And triangle CBD is here. So these triangles actually do look like they are congruent, but I'm not really trying to prove they're congruent. I'm trying to prove they're similar. Now, if I did prove they were congruent, that does then prove they're similar, because if triangles are congruent, corresponding sides are congruent, but also corresponding angles are congruent. So congruent triangles are similar. However, similar triangles are not necessarily congruent. So if you prove congruency, you actually also proved similarity. That's why the wave's on top of the equal sign, because it's like a combination of similarity. It's an extension of similarity. It's not only similar, it's also congruent. So if you prove congruency, that also is sufficient to prove similarity. But we're not going to prove these triangles are congruent. We're going to prove just similar. And so I'm looking for a couple of angle-angle congruencies. And our given is perpendicular, and we know what that does. So AB is perpendicular to DC, so that's going to get this angle. And BC is perpendicular to AE, that's going to get this angle here. So let me state that information. AB is perpendicular to DC, and BC is perpendicular to AE. That's pretty sloppy, but I think you see what I'm saying. So that's given information, and we're going to do our perpendicular process. I'm not going to take a lot of time explaining this because you should really know these steps by now. So angle 1 and angle 2 equal 90 degrees because perpendicular lines form right angles. And then that means the angles are also congruent because all right angles are congruent. Angle 1 is congruent to angle 2 because all right angles are congruent. We've seen this many, many times at this point. All right, so then that's one angle congruence. I need a second. And what we actually have here is that angle B is a corresponding angle of both triangles, right? It's in the middle for both triangles. Angle B is an angle of both triangles. And we don't see this often for angles. We see it more for sides. But we can say that angle B is congruent to angle B because of reflexive property. And so we're very used to seeing sides with reflexive, but you could also have it with an angle, anytime it's a side or an angle. And that's really it. So I have one angle congruence here. I have a second angle congruence between these two triangles. So I could say triangle ABE is similar to triangle CBD by the angle-angle criteria. An angle-angle is similar to a corresponding angle-angle. Are they congruent? Probably, but we don't need to prove that because we're not asked to. If we did want to prove it, we would need to find, some sort of side congruence somewhere, but there's not enough information to give us that. So we actually don't know that they are congruent. They certainly do look that way, but we don't know that. But we do know the fact that they have two angles congruent automatically means that the third angle has to be congruent too. And so the triangles then are what we call similar. See ya. See ya.